Hey there, how's it going? So this is another video about how to create a factorial in Scala. So, but in this video, I'll be showing you how to create a tail recursion in Scala. Currently, I've created a traditional recursion. So you can see after I run the traditional recursion, we have the factorial of 7, which is 5040. And so, say for example, we want to calculate a factorial of 6000 and run the application. So you can see we are getting some error. So this is basically a Stack Overflow error. The reason we are getting error when we're trying to create a factorial of 6000 is because in traditional recursion, we are basically creating stack in every recursion method or function that we call. You can see in this method here, right, we are basically creating a recursion of a factorial, right? So, and every time this function is called, it's going to create a stack. It will store this the value returned by this factorial here. So, and there is a limit to the number of stacks that can be created. So, so if there are too many stack, it's going to create a stack overflow. So, like some sort of memory limit. So that is why it's better to create a recursion that we have a accumulator. So the accumulator will basically store the value returned by this line of code instead of creating a stack. So at the end of the loop or recursive function, it's going to basically return the final output or execute the code and return the final output. So in that way, we are not creating a different stack in every loop. So this is how you can create a recursive a tailrec recursive function. So let's define a new function called factorial of fact tail rec, and so I'm going to give this in and big int. The reason I'm giving it a big int data type is because I'll be using like 6000, 10,000 something, so the return value will be really big. So I'm going to define an accumulator which will basically be storing the return value of the stack, and the accumulator is going to be big int. And instead of giving this one big int, let me give it int. So the accumulator will be big int, and the return value will be big int equal to, I can just give this one int. Yeah. So here I'm going to say if n less than or equal to 1, what I want to do is basically return the accumulator, and otherwise else I want to basically return the factorial. So in each case I will be subtracting the number by 1, so that will be n minus 1, So and then the accumulator will be, so in the first case the accumulator will be basically 1. So in the first loop we have n, so that will be, say for example 5, so that will be n times accumulator, so that will be 5 times 1. Okay, that's the wrong function. So fact tail rec, so n minus 1 and n times accumulator, say for example accumulator is 1, so that will be 5 times 1 in the first iteration. In the second iteration, so we have we're going to have 5 minus 1, so the n here will be 4. So so in the second iteration we're going to have 4 times 5 times 1, so it will be something like this. So for first iteration we're going to have tailrec. So let's say for example n is 5, so we're going to have 5, and accumulator is 1, so we have so this will be 5 minus 1, so the n will be 5 times 1. So in the second iteration we're going to have something like this. So so 5 minus 1, so the n now will be 4, so 4 minus 1, so we now have n times, so it's going to be 4 times 5 times 1. The iteration will keep going like that, but you can see in the first scenario, right, we are basically calling this one and basically creating a stack and storing the return value in the stack. But in the second scenario we are not just returning the factorial, right, we are during the stack call, right, during the function call we are basically storing the our results to the accumulator. So the accumulator will be 4 times 5 times 1, 3 times 4 times 5 times 1, and 2 times 3 times 4 times 5 times 1, until the end of the till the end of the stack, right, the end of the recursive function. And after the end of the recursive function, when n is equal to or less than minus 1, it's going to return the accumulator. That is basically how the tail recursion works. So so let me execute this function now. Print line fact tail rec. Let's say our n is 5 and our first accumulator will be 1, right? So if I now print it, let me just get rid of this. Okay, let's see 7, right? We've got 7. We know 7 is 5114, right? So let's run the application. Alright, so you can see we're getting the same result, 5040. Okay, let's go for 6000 right now. So let's see if we are going to get stack overflow issue. So it's huge number, man. This is really huge number, right? But the thing is, we're not getting stack overflow issue, right? We're not getting that just like we get before. Okay, you can see here that the method is basically tail recursive. You can use art tail rec. So that will specify, okay, this is a tail recursive method. It's not, you don't necessarily have to specify it, but it's something that you can do, to know that okay, to easily recognize your function as still recursive. Alright, that's it for this videos, guys. Thank you for watching. Don't forget to hit the subscribe button, the like button, and leave a comment. Yeah, that's it. Have a lovely day and goodbye.